first, once again, good afternoon and good night to some of our guests who have joined us today. My name is Tae Min from RebuilderAI. If you think about it, when you design something, the process always begins with an idea. So this may be a sketch on a piece of paper or just a concept in mind. But turning that idea or a concept into a real manufacturable product has always taken time, cost, and countless iterations. This is where our company's flagship service, VRINGON, comes in. It's an award-winning innovation at CES. First, just a little bit about us. RebuilderAI was founded in 2022. Since then, we had investment from domestic to international VC firms, including ASICS and Neighbor, as you can see. We were also selected as a First Penguin Outstanding Startup and have been selected as DBAN Global Top 100 Startup, with partnerships spanning over multiple brands in various industries, with awards at CES, IF, and Red Dot. So this is just the timeline. I think we can skip this one. So now coming back to the main topic, as Safir mentioned in the previous presentation, with the growing demand for generative AI, a wide range of AI tools for product design have emerged. So today there are many solutions in the market, such as VizCon, Nano, and Midjourney, just to name a few of the many in the market. Across the industries, so from furniture to automobile to footwear, designers are already using these types of AI tools to accelerate their creativity and to explore a wider range of ideas. However, when you actually take a closer look and dig deep and talk to the people in the industry, we see that while many companies consider adopting these tools, very few actually use them continuously in the wheel production workflow. Yes, of course, they help generate ideas, but they don't all fail to connect the wheel production, the manufacturability. And that's where the disconnect lies. The reason is, in fact, is quite simple. The core problem is not about creating beautiful designs. What companies actually need is design AI tool that can produce designs ready for manufacturing to the real product. Today, we believe we're in this transition phase, so where creativity has become significantly faster with these tools, but not yet fully integrated to the actual manufacturability. And that's where we believe the real opportunity lies. You need to go beyond the inspiration and connect the AI directly to the manufacturable outcomes. Currently in the real world, product development, the biggest bottleneck occurs after the design stage. So as you can see from the graph, once a design is created, 3D engineer must build CAD models, and then manufacturing teams evaluate manufacturability, structural performance, and production feasibility through simulations. If an issue is found at that stage, the design is often discarded and the entire process must start again from design to 3D modeling to simulation. This fragmented workflow slows everything down and increases the complexity for everyone involved in the process. So for fashion brands, 6 to 8% experience launch delays due to this repetitive loop. And each week of delay results in approximately 6% revenue loss, with continuous rework and long and tedious development process. So the real problem here is not the design itself. It's the delayed validation of manufacturability and the lack of integration across teams. And this is exactly where our solution, VRINGON, comes in. VRINGON is not simply a design generation AI. It is an AI model that learns manufacturing know-how and automatically generates manufacturable design data. So starting from a simple sketch or even a prompt, the system generates 2D concepts, automatically builds 3D CAD models, enables real-time editing, runs simulations, and produces production-ready documentation, all within one unified environment. What's critical here is what is important here is that the AI is not just generating design itself, it's learning the manufacturing know-how. So that means every step is informed by real production constraints from the very beginning. So instead of iterating 3 to 10 times across disconnected teams, everything happens in a single loop. So it's faster, more accurate, and it's directly aligned with manufacturing. So let me briefly show you how our solution works. So everything starts with a sketch or a simple concept. Designers upload a hand-drawn sketch or reference image or just an idea. And VRINGON immediately expands that input into multiple detailed design options, allowing teams to explore far more ideas in a fraction of a time without redrawing or manual rework. Through variation, features you can freely experiment with colors, patterns, and materials at the component level. And specific areas of the shoe can be selected and modified instantly, enabling fast comparison across multiple design options without duplicating file or restarting the process. And behind the scenes, VRINGON automatically decomposes the design into individual components. So let's take in footwear, for example. As you can see from the program will identify different components. So parts of the shoe, such as the upper, the panels, lace, midsoles, and outsoles. So this allows instant, precise edits to any part of the shoes, making full design refinement possible. And when the design is ready, VRINGON converts the AI-generated 2D design into manufacturable-ready 3D models and CADs with a single click. Then, of course, finally, ultimately, into a complete tech pack ready for production of the good. Our solution is structured around two core manufacturing data pipelines, the 2D and 3D. So let's take a footwear, for example. I think footwear is, I believe, is one of the hardest products to produce with layer and layers of different components stacked up one another within one pair of shoes. So the upper part of the shoe relies on sewing pattern data, which is managed through our 2D package. At the same time, the shoe needs the sole, and the sole requires 3D mold CAD and simulation, which is handled through our 3D package. Our 3D CAD generation technology is also parametric, so allowing real scale editing without requiring traditional 3D CAD tools. Users can edit models through prompts or segmentations, which is especially relevant for technologies such as 3D sole generation and last editing. What's important is that these two pipelines are fully connected. So it's not a separate workflow, enabling a seamless transition from design to production. So what we focus on is on industries where both 2D and 3D manufacturing data are critical. So this includes footwear, fashion products like jewelry and handbags, to cosmetic packaging and plastic injection-based products, from plastic figurines to even automotive components. Beyond the technology itself, what's critical is how we create a seamless onboarding process and scale with each customer. So we start by automating the process of tuning the AI model using company-specific data. So this allows us to build highly customized AI model that reflects each company's manufacturing conditions, workflows, and design rules. So these are very specific to each company. In the first phase, we work closely with the customer through consulting and customer build, integrating their data, setting up pipelines, and training the AI on their product logic. Then we move into a free pilot program where the system is applied to one or more real product lines. Here we validate performance, measuring improvements in lead time, cost reduction, and approval rates. Once the results are proven, we transition into a full commercial deployment through an annual license model. At that point, the AI continues to improve over time, learning from companies' data, creating a strong feedback loop and long-term value. Also, you can see from the presentation, we offer a free demo of our service upon request. So if you're interested, please feel free to reach out after the webinar or leave a comment, and we'll be happy to set that up for you. Traditionally, the manufacturing industry has relied heavily on complex 3D CAD and simulation workflows. While these systems are powerful, they are also highly manual. So this requires specialized expertise and are difficult to scale across teams. On the other hand, generative AI tools are easy to use and highly automated, but they often lack real integration with the real manufacturing process. So what we've done is trying to bridge this gap. And our solution integrates generative AI directly into the traditional engineering workflow, combining ease of use with real production capability. So this is making it easy to use for everyone in the team. One of our key differentiator is the loop system. So the system continuously learns this, and this may be company's design preference, or the manufacturing know-how, or accumulated experience. And based on this, we build a company-specific designer or a engineer personas, enabling AI design agents that continuously improve over time. So in other words, this is not just a design tool, it's a system that allows each company to build its own AI agents trained on its internal knowledge. And this ensures that critical expertise or the know-how stays within the organization. Even as teams evolve or experienced individuals move on and, let's say, retires, the data stays within the company. Over the past several years, we've built a unique foundation of extensive 3D manufacturing data collected from both the brand and the factory sites. So this includes not just design data, but also cost structures, materials, and real production constraints. And by connecting these two worlds, so the designers, brands, and manufacturers, we've been able to structure data that traditionally exists in silos. So on one side, we understand design intent and trend-driven requirements. And on the other, we capture the factory capabilities, limitations, and cost drivers. And by combining these data sets is what powers VRINGON. So today, that translates into over 400,000 3D data assets, more than 10,000 design explorations, and hundreds of manufacturing cost data sets. And this is our core advantage. An AI trained not just on design, but on real manufacturing intelligence. As a result, we have achieved real performance improvements, such as reduced production lead times, minimized revenue loss from delays, significant improvements in design efficiency. And today, our solution is being used by global brands and manufacturers across Europe, Asia, and the United States. Until 2024, our focus was on building a foundation. We've developed a 3D scanning and data generation technologies and accumulated over 400,000 paired 2D and 3D product datasets. At the beginning of 2025 is when we launched VRINGON and started deploying category-specific pipelines to leading companies across industries. Now in 2026, our focus is on expanding the feedback loop. So this means companies can continuously train AI models on their internal knowledge turning their expertise into persistent, scalable AI assets. Then starting next year, we take this a step further into an AI agent. Instead of single system, companies were able to deploy multiple specialized agents, for example, designer AI agent or engineer AI agent, each trained on different roles, capabilities, and datasets. And ultimately, this will lead to full vertical integration where the entire design to manufacturing workflow is connected, automated, and continuously improving. So basically, to summarize, by unifying AI-driven design, intelligent automation, and digital manufacturing into a single seamless workflow ecosystem, VRINGON enables brands to move beyond the fragmented and outdated workflows. So designers, development, validation, content creation, and even factory-ready outputs are no longer separate steps. They are becoming a more of a one continuous and connected process. And this is how we define how products are created faster, smarter, and directly aligned with manufacturing reality. Thank you.